I mean, look, what we do is really hard. Like the space environment is nasty. Think of the nastiest environment you can and then make it a bit worse.
Welcome to The Future Of, a podcast by Fresh Consulting, where we discuss and learn about the future of different industries, markets, and technology verticals. Together, we'll chat with leaders and experts in the field and discuss how we can shape the future human experience. I'm your host, Jeff Dance. In this episode of The Future Of, we're joined by Sir Peter Beck, who is the founder, president, and chief executive of Rocket Lab. Today, we'll be exploring the future of space innovation. Sir Peter, welcome to the show.
Yeah, no, pleasure to be here.
Yeah, thanks for joining from New Zealand. Which part of New Zealand are you in?
So our factories are here in Auckland, and the launch site is over on the east coast. So about a 2-hour helicopter flight or a 8-hour drive.
Amazing. Beautiful place to be. Having been in helicopters in New Zealand doing some heli skiing, it's just mind-blowing the terrain you have there. So you're blending a lot of amazing things together.
It's a good way to go.
I wanted to start with a little intro, so for people that haven't heard of Rocket Lab or Sir Peter. Sir Peter Beck is the founder, president, and CEO of Rocket Lab, and Sir Peter has led the development of Rocket Lab's satellite launching rocket Electron, which is, as of April 2025, has launched 63 times and is now the second most frequently launched U.S. rocket. Congratulations. He's also, an adjunct professor in aerospace engineering by the University of Auckland. In 2024, Peter was made a Knight Companion of the New Zealand Order of Merit for services to the aerospace industry, business, and education. He's also been presented with numerous medals, like the gold medal from the Royal Aeronautical Society. You have a really impressive background. And as far as Rocket Lab, it was founded back in 2006, correct?
Correct.
And it's a global end-to-end space company delivering launch services, spacecraft, satellite components, and on-orbit management. So really interesting company as we think about the future of space. So grateful to have you on the show. I wanted to start with, why space? There's not many people in the industry. We work for a couple of space companies, but there's not many of them. I know it's a growing industry. What kind of drew you to this career kind of early on and has kept you so dedicated to it?
Well, I mean, the space industry is raucously difficult, and like a lot of entrepreneurial endeavors, it's also very, very painful. So you have to have some level of passion to kind of endure it, if you will. And for me, one of the youngest childhood memories I actually have is standing outside with my father, and he would pointed to the night sky and said, "Well, all of those stars the majority of those stars are suns, and they could have, a lot of them have planets around them, and there could be somebody standing on that planet looking back at you." And that was kind of the moment. It's like, right, this is really quite interesting, and this is where I have to spend my time. So I was very lucky that I knew from almost some of my youngest memories exactly what I wanted to do, and was able to guide my career to doing exactly that.
Yeah, congratulations. You have an interesting kind of evolution as you think about your career and kind of where you started to kind of where you are now. It's not many people that get into this opportunity. What do you think kind of helped catapult yourself into being both a founder and CEO of a successful company in space?
Well, my original plan was to go to the US and work for NASA, but as a foreign national with no aerospace degree, that proved very troublesome. So really, I did the only logical thing that you could do, which was go back to my home country and start a company. I can't say that the original design was to go and start a company. It was just the only pathway that I could see that would get me to where I wanted to go.
Fascinating. NASA's a good place too, but we need more. Organizations around the world, given where the future of space is going. That's great. We noticed that Rocket Lab was selected to provide the hypersonic test launch capability and kind of other services to both, not just the UK government but also the US government. Tell us more about that.
Yeah, so the Electron rocket, which is our small orbital class rocket, has been very successful in delivering hundreds of satellites to orbit, and we were kind of tapped on the shoulder to try and provide this new capability, which is a suborbital capability to test hypersonic platforms and programs and those kinds of things. So it's really taking a product that we already had and extending it on to provide these useful services.
That's great. It's interesting kind of looking at your company because you guys do more than one thing, as it relates to space. There's the satellites, the spacecraft, the subsystems. So you're not quite like in a singular thing. Your website says that you're transforming the way we use and access space. Tell us more about kind of your strategy with tackling it from multiple angles.
Yeah. I mean, some days I wake up and wish we just did one thing, but the reality is, we're trying to build an end-to-end space company, and
Mm-hmm.
what does that mean? Well, what that means is typically the space industry is very bifurcated,
Yep.
and you have little companies doing very bespoke, unique things, all at subscale. And that's all great if you're building like one or two things a year and launching them.
Mm-hmm.
But when you're trying to build, a constellation of hundreds or thousands of spacecraft, then that becomes very, very, challenging. So our view is that, obviously launch is the enabler. Like having the keys to space is really the most important thing. So that's why we have our Electron rocket and soon to fly neutron rocket. But very
Nice.
quickly thereafter, if you can combine the ability to launch stuff and also build the satellite at the same time, then it becomes a very, very powerful way of deploying infrastructure to orbit really, really quickly. So we said, okay, we're going to build satellites as well. And one of the first things we did was we laid a satellite out in a component level out on a boardroom table, and then asked everybody to point to everything that sucked, either from a technology perspective or from a supply chain perspective or from a cost perspective.
Mm-hmm.
And I can tell you that there was almost no component left that wasn't being pointed to. So as we started to go through that, we methodically went out and we did a couple of different things. One, we went and either acquired the best technology and the best companies, and then subsequently scaled those to an ability to actually produce at scale. Or we just started off our own internal R&D programs, and with the ultimate same end result of providing scale. Because generally, if you go to the vast majority of the space industry and you rock on up and say you want to order 1,000 of something, you just watch people's heads kind of spontaneously combust, because that is a number that is just not common within the space industry. But
Right.
as you think about where the space industry is going in the proliferated LEO architecture, as in putting up a bunch of satellites to provide services to all of us down here, then somebody has to be responsible for the ability to scale the satellites, the components that go with them, and launch. And my prediction of the future here is that it's going to become pretty blurry about what is a space company and what is a services company. I mean, take our friends over at SpaceX right now.
Right.
Is SpaceX a space company, or is it a communication services company providing internet? It becomes pretty blurry pretty quickly. But the one thing that's true there is that if you have the ability to build the infrastructure and deploy it through launching it all by yourself, then it creates a capability and a moat that, unless you have that capability, it's very, very difficult to compete with. So we've just sort of in traditional Rocket Lab style gone through and about this in a very methodical way, picking off each bit of technology and each bit of capability one after the other, to ultimately, build this end-to-end space company, which is unique in the industry.
Yeah, no, it's special. I think, at Fresh, we're an end-to-end innovation company with these engineering services, design services, software services, but it's our competitive advantage, but it's also our weakness. And that's like there's a lot that we're tackling at once. But when you have a really challenging innovation problem, and you can bring all that stuff together. It's hard for anyone else to compete, and
Yeah.
I would echo what you're saying in the same way. It's like you have all those services. Oh, you can not only build the satellites, you can launch them, but then you can manage them.
Hmm.
That you're kind of providing all those pieces, all that complexity. You're simplifying it for your customers essentially, and bringing all that complexity into a single house. I definitely see the value, and it's pretty compelling. Tell me more about how you guys differ from some of the other players in the space. So you mentioned SpaceX. Who are some of the other major players in space that you guys are competing against? And then are none of them providing kind of the full end to end services that you guys are providing?
Yeah, from an end-to-end perspective, there's not really anybody, right? But in kind of various component levels, there's some competitors, some very robust competitors, and then just some things there is just not. I mean,
Mm-hmm.
take space solar as a good example. I mean, there are 3 providers of space-grade solar cells in the entire world. One in the US, us in the US, and one in Europe. And
Mm-hmm.
between these 3 companies, they provide all of the space grade solar cells for the world.
Wow.
And we're now the largest in all of that. But there's an example where there's really only 2 competitors, and that's not uncommon given the complexity and the scale and the nature of some of these things.
Mm-hmm.
So whereas some other components like reaction wheels, for example, there's probably about a dozen companies that are all providing that particular product. So but look, the space industry is a weird industry because we'll go head to head with a prime on a big space mission, and then if we don't win, then that prime turns around and orders a whole bunch of components from us, and we're now a
Ah.
team. We're now a teammate. And we are a teammate. We work as a team. So it's kind of competitor mate. In the industry where you can be in kind of raucous competition, and then the next day we're having a kickoff meeting and we're best of friends.
Wow. That's really interesting, and I would imagine it requires a lot of that, given all the challenges that the industry faces. You mentioned one, just being so few suppliers of these solar cells, but
Mm,
what are some of the other? We've heard in space, obviously there's the extreme cost that are coming down with
mm,
with companies like yourself, but there's the legal side. There's the sustainability side. We've talked in a previous episode. We talked about all the space debris that's up there.
mm.
There's some of the technology side from unreliable kind of communications or limitations. But what do you see as some of the biggest challenges that the space industry is up against?
Yeah, yeah. When you put it like that, it's a little bit depressing. I mean, I wish it was a bit easier, to be honest with you. But that I mean, look, what we do is really hard. Like the space environment is
Right.
nasty.
Yeah.
Think of the nastiest environment you can, and then make it a bit worse. So, and it's a really really difficult thing to go and do. And there's the old saying, "Space is hard," which is even today is proven to be absolutely true. But I think
Yeah.
one of the biggest challenges in the space industry is not really the technology. It is just the ability to scale, because it has
Mm,
been an industry, a cottage industry, for so long,
right.
that the industry really hasn't built a good infrastructure, supply chain, and all of those things to be able to scale quickly.
Hmm.
And that's the one thing that I would say, our customers come to us, and scale and schedule is number one, technology is number two, and then price is number three. So
Interesting.
and that will change over time, but
Hmm.
the scarcity of launch, the scarcity of so many components and bits and pieces, just that's the biggest challenge facing the industry right now.
Makes sense. As far as the makeup of customers
Hmm.
in the space and in your area, like what is the mix between government and commercial?
Well, we like to hold sort of 50-50, so 50%
Hmm.
government, 50% commercial. Now, a number of other companies are, can be 100% government or 100% commercial. But
Hmm.
it's fair to say that governments definitely are a large customer of this industry, because a lot of the infrastructure that goes in orbit is government related, whether it's civil or
Hmm.
defence.
Yep.
So yeah, certainly a government is a huge customer.
Mm-hmm. As far as like near-term market opportunities, we've seen how quickly, SpaceX, once they, had stabilized their system, started to turn on a lot of commercial,
Mm,
avenues of that capability. And it's been interesting that the everyday user now is, on their mobile phones are getting like this, access to
mm,
satellite reliability, and people to understand that the world has cell phone coverage, but what percentage of the world does not have cell phone coverage is much larger, right? And so
exactly.
when you can put those cell towers in space, right, then it changes the dynamic of coverage, and it creates a lot of interesting possibilities for new business. And and so the Amazon and Kuiper are kind of
Hmm.
working on a similar network. We know there's companies in Europe that have been working on kind of similar things. I would imagine China and Russia are also thinking about like, hey, how do we have our network that helps us in
Yep.
in commercial, but also wartime? Because this has now become a strategic advantage
Hmm.
to the communication front. So I'm curious as far as like some of the market opportunities you see that are really kind of hot right now for space.
Yeah, no, I think you've hit the nail on the head. Obviously, commercial comms is a huge opportunity, and I would say, look, we're right at the very beginning of this, right?
Mm-hmm.
This is a very very early execution of the system, and look, I've always said that I think that the biggest application in space hasn't even been thought of yet,
Mm,
and with this kind of direct device comms and internet from space. It's really been enabled by low cost access to space,
right.
and that's not going away anytime soon. And there's more providers of that, including us, for example, of that. So that just enables so much more. So I think it's I guess a good analogy to think about it is when the internet was first created,
Right.
it feels like we've sent our first email. That's I
Right.
think where we're in the kind of the progression of what you can do in space is really at.
We're at the baby stage of
Yep.
of where it's going. Yeah.
Yeah.
Very early stage. That's fascinating. What's fascinating about uh, that future, and let's get to that, is we can see some of these satellites, right? Like you
Hmm.
can see uh, you when Elon launched all these new satellites, you can see them, right?
Hmm.
And so, but the world's a big place. Like we have like how many hundreds of millions of cars do we have on the planet? I'm curious. Like, do you see the the launch of so many more items uh, having like a crowding problem up there, or is this not a non-issue because we're like the space that the amount of space in
Yeah.
space is so big.
Yeah.
Like
Yeah. Yeah.
I'm just curious to ask you. It's maybe a dumb question, but
No. No.
interested
No.
in your input.
No. Totally. It's a great question, actually. So yes, space is big. And if you took all the spacecraft that are in orbit, it would probably fit in a football paddock. So you think it. So there's not that much, metal flying around in orbit in the grand scheme of things.
Interesting.
However, it's also kind of like having a highway with zero rules, as in no traffic
Mm.
lights, no intersections. I don't care if you're going up the road or down the road, cross the road, it doesn't matter. Just go. And and doubt it. When the highway's not busy, then the chances of you t-boning somebody is pretty low.
Yep.
Um, but as the highway gets busier and busier, those chances, continue to increase until it becomes inevitable.
Mm.
So, there is going to have to be a global space traffic management thing.
We need
And
traffic control in space as
we
well.
do, we do, just
Yeah.
like aviation, just like on a set of rules in the motorway. Like, I mean, it's just
Good analogy.
yeah. So that has to happen. Now,
Mm.
the challenge for everybody is, unfortunately, it's a little bit of a human condition to wait until something all turns to crap and then
Mm.
do something about it. And it's not like just the US can put this in place because
Yeah.
everybody's going around the planet every 90 minutes. So
Right.
there's no kind of, well, let's stop and detour around China for a moment. Like we are
Right.
going over China, just as we're
Yeah.
going over every other country. So
Yeah.
all of the countries, the whole globe has to get together and agree on a
Mm.
set of rules and norms that would enable space traffic management. Then I think it's no problem at all.
Yeah.
But until that happens, then we're literally on the highway, somewhat blindfolded, flat out.
Blindfolded, flat out. Okay. So is that something you're going to tuck into your responsibilities and end-to-end space management, or is
Oh
there a
yeah,
body? Is there some
because
sort of body that's trying to bring these countries together?
yeah, because I'm the guy who's going to create a global agreement.
Yeah.
In saying that, though, I did go to the UN a number of years ago and talked about this, and
Yeah.
it was singularly the most awe-inspiring and depressing thing at the same time, because it was great that it was awe-inspiring that all the countries turned up to talk about this. So clearly, everyone recognises it's a global issue.
Mm.
And everybody read their own pre-prepared statement, and I was kind of like chairing a panel on this, and everybody read their own pre-prepared statement, and at the end of it, I'm like, right, let's just go and have a whiteboard session, sort this out, and there was like deafening silence there, and I realized that within the UN there hadn't been a global kind of outer space rule agreed since the 1970s when the Outer Space Treaty was signed. So
Wow.
it's not an area that has been successfully kind of conjoined and agreed on over history.
It seems like something ripe for conflict. If we can contemplate that we're using this for military purposes, we're wanting countries are thinking about it more from a military perspective. Not that they haven't used it for intelligence for a long time, but it seems like if there's no rules and we got these strategic assets in up there that cost a lot of money, and then bumping into each other accidentally or maybe on purpose could be a place that's ripe for conflict without more unification.
Yeah. And like I say, I think I've sort of resolved myself to waiting until there's kind of a big enough issue that everybody goes, oh, okay, yeah, no, we need to talk about this now.
We need to talk. Yeah. Okay. Interesting. Well, let's start hearing more or hearing more about the future. At least talk about more of the future. We've talked a little bit about today, some of the challenges, some of the incredible things you're doing to kind of bring this together for companies and for markets. What do you envision? As we think 10 to 20 years ahead, you talked about the need for unification for rules. I would say that's something
Mm-hmm.
that sounds really important for 10 to 20 years from now, hopefully sooner. What other things come to mind from your perspective as we project forward?
Well, I think overall, everybody will be, the space layer will be much more connected in everybody's everyday lives. Now,
Mm-hmm.
it already is, but most people don't realize it.
They don't
Whether
know
no, I mean, like you order a pizza, the reality is that's come from space. Now, that sounds a crazy thing to
it.
say, but I mean, if it wasn't for the GPS, your pizza would not have turned up at
Fair,
your house. Uh,
fair.
so we, there's everyday stuff that we do that is relying on space
Mm,
infrastructure, but
mm,
it's hidden infrastructure, and it's just not that obvious. Now, I
right.
think satellite comms has become a little bit more obvious because everybody knows that they're talking to a satellite at least. So that's become a little bit more obvious. But as that becomes normalized, I think it will just be, we'll look back and go, oh, remember those days that you didn't, that time when you didn't have like ubiquitous cell phone reception? Remember having to sit on a plane and just like the maximum you could do was an email? All of these things, it's not 5 or 10 years, it's like 10 months away. So,
Yeah.
so I think there'll be pretty significant, quality of life changes to a lot of folks because of the space infrastructure. And then there'll still be all the hidden layers, the weather satellites up there that are providing, weather data to provide weather forecasts and all those kinds of things. We've talked about GPS, the Earth observation satellites that are providing, imagery and things like that. That you may not realize, but will soon be integrated into so many things. If you've got real-time imagery from space, then, for example, you could monitor all the traffic in a city and kind of predetermine traffic jams and all of those kinds of
Mm,
things.
mm,
So, there's a plethora of kind of capability that can be, can be exploited in space that I think, will become obvious for some people, and it'll just kind of integrate into the global infrastructure and be completely oblivious. But
Right.
everybody's life is going to improve.
Mm-hmm. Mm-hmm. That's cool to be able to say that everyone's life will be able to improve. But I think once you understand, connectivity to information, and you can tap the world's information no matter where you are.
Mm.
I don't know what percentage of the Earth isn't covered by cellular service, but there's a lot of issues that, whether you're deep sea or deep mountains, that come with connectivity. And
Well,
go ahead.
Well, if you look at the world and what is the distinguishing factors between a first world nation and a third world nation, well, it's largely education.
Yeah,
And if you can take an online Stanford course in a mud hut in Africa,
yeah,
then your quality of life is going to improve. So
exactly.
yeah, having that ubiquitous dissemination of information and knowledge is going to be great.
It's one thing to have that knowledge available over the internet. It's another thing to have that ubiquitously available on a device that's inexpensive to be able to
Hmm.
kind of tap that information. Yeah.
Exactly.
That's fascinating. One of the things that we've been noticing with robotics in particular is how AI has been accelerating that. And it's
Mm.
sort of like people, we get excited about ChatGPT and how AI and deep, agentic AI is. That's been really fun to watch this year. How much deeper AI can go around problem solving, and produce really valuable analysis. But
Mm.
computer vision, has been a game changer. I mean, it seems like from zero shot, being able to like do communicate a lot of information via computer vision to robots or to cameras in general. The intelligence that you can pull off of a camera these days without doing a lot of training is really fascinating. And I was curious how AI and computer vision kind of tie into how things are accelerating in space. If you
Mm.
anticipate a lot of innovation as a result of AI and computer vision.
Yeah, totally. I mean, and you can kind of bisect that into on the ground, kind of doing the creating, and then the in orbit. So from the in orbit perspective, of course, you've got Earth observation satellites. They're taking images and imaging, the whole world every day. And if you're imaging the whole world every day, then you can see a lot of stuff. And
Mm-hmm.
you know, that is just like the ultimate example for machine learning and AI
Right.
to be able to build terabytes of database every day and then just query. It's like, wow, I wonder what happened over here, or are there any changes in the forest today? Yeah, there
Mm.
was like 20 people cutting all these trees down this afternoon. Like that
Mm.
you don't have to go hunting for that. It's just a query
Wow.
of a database. So that becomes very, very powerful. And
So
then
hold on a second. I just want to make sure I capture this. But we can grab this large data set on a daily basis, almost as a large language model. And then because we have
mm,
the AI of today as a conversational interface over that large database, we can query kind of the changes of the world on a real time basis. Is that
yeah,
a
I
good
mean,
synopsis? Yeah.
totally. You
Yeah.
should have Will from Planet Labs on your show and get and talk to Will about that, because this is exactly
Mm.
what Planet Labs as a company is doing. So yeah, no, there's just tremendous power there to see insight for sure.
Nice. I cut you off though. You had
Yeah.
there was
So
a second thought. Yeah.
yeah. Well, so the other part is on the ground.
Mm.
And like when every electron flies, there's about half a terabyte of data that comes down from each flight. We have like 15,000 channels of data acquisition on that launch vehicle. So,
Wow.
that's a lot of data to ingest. And, if you're just some poor engineer sat at a desk and trying to compare, like, wow, was that combustion chamber profile of chamber
Mm-hmm.
E9 the same as the last 60 flights, or was it different?
Mm-hmm.
You can do
Yeah.
that. It just takes a lot of time.
Mm.
But being able to ingest that and just query through AI, then and then pull some insights out of that, then that's just one example for us. Where we're deploying AI throughout our business,
Yeah.
and then in more traditional places in finance and whatnot. But I think doing the things that we do is going to be made easier with AI. Um, from coding and well understood there. But I mean, even from data reduction analysis and all those kind of things,
Mm.
it's just So I think it's going to have a big impact.
Yeah. I think the notion of all these sensors getting data and you producing that sizable amount of data, like how you take big data but then turn it into little data that is actually meaningful, right? It's like this is where AI overlaps like completely,
Exactly.
and then tuning that to make sure you're getting valuable insights, so it's not just noise.
Yeah.
It takes some work, but that's available today. It's not like this isn't like futuristic technology. This is what we're doing essentially,
Yeah, yeah, and,
right?
and we've already employed it in some of those example data sets, and
Yeah,
it's stunning what you can achieve, and what took some engineers days and days and days to do
yeah,
is reduced down to minutes.
that's amazing. I mean, does Sir Peter look at 30 different monitors up on the screen and he's like analyzing that real time, or do you just get a text with showing you the four insights that you need to be aware of because the AI kind of harnessed all of that information that we're looking at, right?
Wow. Unfortunately, I'm a geek, so I'm I'm
Yeah.
I'm down in the raw data still. So
Okay. Yeah. All good, all good. Oh, that's fun. I bet it's fun to be in the raw data. So
mm,
that's fascinating. Well, this has been really interesting. I have a few more questions to kind of close this out. But one was around, the people that are going to be in more demand in the future as we think about the space industry accelerating, those that are interested in getting involved like you have. You got involved at a young age, which is unique, and has been part of this journey for a long time. What would you say to them as far as some of the types of engineers or specialists that we'll need in the future? And it could be more of the same, but
mm.
I wanted to ask.
Well, so firstly, and this goes just doesn't go with space. I think it goes for any someone starting out in their career. It's like
Yeah.
find your passion, right?
Hmm.
Because there's going to be highs and there's going to be some lows. And in the space industry, you literally work your butt off for months or years for one giant event that either will go spectacularly well or spectacularly bad. So it's a very digital outcome. So you need to be very passionate about about what you do. But I would say, look, one of the areas that we continually struggle for is mechanical engineers. So
Hmm.
as an example, so look, I'm sure AI will certainly help a mechanical engineer develop various things, but
Right.
there's a bit of a blurry line, especially in the space industry, between good design is a blurred line between art and engineering or art and
Mm.
science.
Mm.
And the very, very best designs look incredibly simple, but they've probably taken the longest to do because
Mm.
that's just what good design looks like. So I think that's an area where there's always going to be a huge demand. Software and coding, there's always going to be some really niche stuff there, but as we see over time, the more kind of mundane tasks, AI can do a great job of. So
Right.
and maybe it's just me because I'm a mechanical engineer, and AI is a boom right now, so everybody's in software, but actually
Yeah.
don't forget you need the hardware to do the software.
Yeah. I definitely think it's an interesting space. We've seen the tide turn a little bit on the demand on software engineering given the acceleration of AI. Also,
Mm,
some of the things that have happened in the market dynamics with kind of tech companies. But it seems like hardware has emerged as something that's continued to be important and growing. And sometimes you see ebbs and tides between hardware and software, but it
yep.
seems like right now we're seeing more of an ebb towards some of the hardware oriented companies. And that would go back to, hey, mechanical, obviously electrical as well, but some
Yeah.
of the mechanical engineering fundamentals that underpin good, but innovative engineering.
Yeah. Exactly right.
That's great. Last two questions. One is, what are some of the advancements in space technology that you're personally most excited for? And that could be something you've already said, but I just wanted to ask.
Well, I'll answer this in a little bit of an odd way. The thing that I'm most excited for doesn't exist. So it and we've spent a bit of resource trying to figure it out as well as many others. But the biggest limiting factor for any space activity is the fact that, somewhere between 1 and 5% of the total mass of the rocket is the actual thing you put into orbit. So if Earth's gravity was just a little bit higher, we wouldn't get anything to orbit. The atmosphere was a little bit more dense. I mean, it for whatever reason, it's just possible. And whoever, if there was some designer of all of this, they'd be sitting back in their chair chuckling away, going, "Man, I've just made it real hard for these guys, and they're struggling." If the Earth's mass was just a little bit less or whatnot, it'd be so much easier. But the reality is, we achieved combustion optimum efficiency back in the 60s. So there is no propellant combination that you can put together to make a higher performing rocket engine. That's it. Like hydrogen and oxygen, that's your lot. And the trouble is that even with that, it's like 1 to 5% total mass is the thing you put into orbit. If we truly want to be a spacefaring civilization and transit the solar system, man, we've got to find a way better job than burning dinosaurs to get off this planet. We really chemical propulsion it works, but it just works. Yeah. Yep. So, I'm rooting for the antimatter drive, the ion drive, or some other alternative.
Dark matter drive.
Anything.
Is nuclear? Is that a step?
Nuclear's great. Nuclear's awesome. I mean, you can get the best you can get from a hydrogen oxygen engine is about 400 seconds of ISP, and ISP is a measure of performance or efficiency. Nuclear engine you can get up into the thousands, which is great. There's just a little bit of an issue that you just got a nasty stream of radiation.
That's true.
All the way to orbit, which is suboptimal. But in space it's a great technology. But the hardest thing is getting off the planet, and until we really crack a different way of propulsion, a different way of providing propulsion, then you end up with comically large rockets to do put relatively small amounts of mass into orbit.
Comically large is an interesting way to look at it, but it rings true. That's fascinating. Very deep. Last question. That is, what's the most kind of rewarding experience that you've had in the industry so far? You've accomplished a lot, and a lot more than most people do in a very kind of end-to-end way. It's impressive. We're excited to keep watching where you go. But people ask me sometimes, and I just run a small company of 400 engineers, but tell us kind of as you look back, what would you say has been one of the most rewarding experiences or accomplishments?
Oh, that's a really tricky question. That's almost asking me to talk about my feelings, which is equally as. So I don't know. I mean, look, the technology and the accomplishments, is awesome. I mean, we went to the moon with a mission off Electron. That was amazing, and we've re-entered capsules, and there's just been so many, I guess, technology moments or spacecraft or space moments that have been amazing. But I guess one of the most satisfying things for me is actually just watching the team grow, and you take I think back to we were just a bunch of in many cases graduate engineers kicking around in a little lab, and those guys now are vice presidents running big parts of the company, responsible for huge things, and are amazing people. And even today, I induct everybody who comes into the company, and it's always really, doing it long enough that I've seen enough, really early stage graduate engineers who and you sort of know because they're just full of beans and gonna make it happen no matter what. And that's one of the great things about Rocket Lab is you can start as a graduate engineer and end up as a vice president in a relatively short period of time if you kick ass. So that's super fun to watch.
That's awesome. Yeah, it's one thing on the technology side, but the human side, the people side, and being able to watch people grow through overcoming challenges, hard challenges, really hard challenges, and seeing that grow into a successful business. And congrats. Proud of what you're doing and excited to watch what you guys accomplish in the future. It's our pleasure to have you on this show, and grateful, Sir Peter Beck, for what you're doing and your passion. Can hear it, can kind of feel it. So congrats again, and thank you for coming on. The Future of Podcasts is brought to you by Fresh Consulting. To find out more about how we pair design and technology together to shape the future, visit us at freshconsulting.com. Make sure to search for The Future of in Apple Podcasts, Spotify, Google Podcasts, or anywhere else podcasts are found. Make sure to click subscribe so you don't miss any of our future episodes. And on behalf of our team here at Fresh, thank you for listening.